Good morning. Good morning, everyone. Thank you for being with us this morning. My name is Patrice Marcel. I will be your host today for this webinar. And let me just bring some slides here on the screen. Go. Yeah, today is December 1st. Can you believe this? Already December 1st. Wow, see, the hockey season is on. Somebody should tell the folks in Montreal that it is. It doesn't seem to know. Anyway, so hey, thanks again. Thank you for joining us. I see that we have quite a good crowd here and still some people signing in. This is part of the education series that we started a couple of years ago. So we are at our third year, I believe, of this event. These are kind of 60 minutes webinars that we organize. We have technical and management. So today's the technical one. Tomorrow we have the management one. And we focus on the equipment, products, services, and manufacturers, everything that is relevant to what you guys are doing. So we're happy that you are with us. And if you would like to present, if you'd like to make a suggestion or some topics you would like us to discuss, hey, all the information is right there. You can go on the CCIF website and apply to be a speaker. There's an application form that you can fill. Hey, we'll be more than happy to welcome you here and help us do that. I mean, that'd be nice, actually. So it is possible for you to do that. A little bit of housekeeping. Yeah, you can definitely ask some questions. This is Zoom, so you just click on the Q&A. You can click on the chat as well if you want to post a comment. During the webinar, I will be kind of monitoring this, so you can put your question in there, and I will make sure that we bring it up to the audience here. Other than that, what is very important here, as always, is that the CCIF is a non-for-profit. We're there because of our sponsors. I mean, and that goes back 22 years ago when this was created. And I mean, we've had so much support over all these years, so it's important that we thank all of our sponsors. So we have the diamond sponsors we want to thank. We have a bunch of gold sponsors as well, so thank you very much. And then we move to we have the silver sponsors coming up right now, and a lot of them. So thank you very much. This would not be possible if we wouldn't have your support, specifically and especially in those kind of weird times that we've been going through. So this is bringing us to the topic of the day, which is to provide you with a general overview of electric vehicle safety. It is. I mean, it's a big topic. It's a topic that is not going to go away. It's not something that is just, be there for a moment. It is there. I mean, and it directly affects everything that you are doing. So it is very important that we start talking about this. So the previous webinar that we did in the summer, we touched on electric vehicle. Now we decided to go a little more deeper in it, even though, I mean, we're probably only scratching the surface here, but that's an important topic. So this is recorded. It is possible for you to review it, or if you have a colleague that is missing it, it's possible for this person to go to the CCIF website in a couple of days, and you will be able to review this webinar. So the format today that we are going to be using is an interview style. So we're going to focus on two things. Let me go back here. We're gonna focus on the vehicle safety and on technician safety. There's two kind of main focus. We want to do this, and that's going to be done as an interview. So we have a subject matter expert. So we're happy to welcome Mark Nilsson as a subject matter expert. So quickly, Mark has been with Excellence Auto Collision for 12 years. He's the director of operations for their 2 locations in Toronto. 60,000 square feet of production space. Mark represented Canada as a international skills competition. So I had a chance to talk with him a little bit about that. And that's interesting. This is nice. It's nice to see that we have Canadians that made it up to this level. So very involved in the industry, staying current with OE certifications and accreditations. Mike's purpose and drive is to help educate technicians to not only repair cars in the best of quality, but the best in safety as well. So just going to stop sharing here, so maybe we can see Mark here. And Mark, do you want to tell us a little bit, just maybe a minute about the Excellence Auto where you work?
Yes, thank you. It's a pleasure to be here today with everybody. I think this is a unique opportunity to share my experiences over the years here at Excellence Auto Collision with the industry. I hope that everybody takes a little bit of information out of this seminar and really takes it upon themselves to build their own wealth of knowledge, because as you were saying, electric cars aren't going anywhere. It doesn't matter what OE we look at, the electrification of the automobile, 50% of the car park could be electric, you know, in the next decade or so. So it's really exciting times. Here at Excellence Auto, I've been here for 12 years, like you mentioned. Kind of started as a technician and made my way up the ladder into management here. We have 2 locations in Toronto. We're certified by BMW Mini, Audi, Volkswagen, Porsche, Mercedes-Benz, and Tesla. And we have a couple brands that we'll announce in the near future that we're adding on. So we're really always focused on the OE certification. Ultimately, one of the biggest benefits that comes out of any OE certification is access to information, right? The information is key. Now, whether we're talking about electric vehicles or just structural repairs, if we don't have that information, you know, unfortunately, it's just guesswork, right? So that's why we have such a passion here for that. We want to repair cars correctly. We want to have that information, you know, and if we just look at the short time, you know, since 2013, when electric cars started to come to the market, and look where we are today, you know, if you don't have that information, it is changing so quickly. There's no way to keep up. You know, you just can't retain that much information. So
you're absolutely right. So just to, of course, just to continue, and thank you for that, you know, for that moment here, introduction, Mark. We have I mean, I mentioned it's an interview style, so it takes at least two person to do that. So we're very pleased to introduce Vanessa DeVito, which is also a member of our education committee at the CCIF, to help us today with the interview. So Vanessa is the owner and founder of AutoPlus Performance, which is a full-service automotive marketing and solutions company specializing in generating growth in sales, traffic, and customer retention for collision repair facilities across North America. So Vanessa has been in the business for almost 20 years. Vanessa used to be a colleague of mine for a couple of years at Axalta, and I'm very happy to welcome Vanessa. So Vanessa, do you want to just give us a little
Yes.
About yourself and your company?
Yeah, so thank you, Patrice, and thank you everyone for having me on here. So a little bit about myself. I've been in the industry, working in the industry for the last 18 years, and I've had the opportunity to travel across Canada in various roles, as well as the United States. And during my travels, I've been in over 500 collision centers, and I've seen an opportunity where there is opportunities for collision centers to be able to grow in sales, traffic, getting additional customer loyalty. So when I left my previous role, I decided, you know, I'm going to follow my passion, which is to really help the industry make it a better place and help businesses to grow in sales and customer loyalty and change with the digital advertising and marketing world as well. And so, yeah, I opened up my business, and now we offer quite a few different service packaging. So,
yeah. Okay, well, thank you. So there's two, as I said earlier, there's kind of two big topics that we want to tackle today. The first one is about the vehicle safety. The second one will be about the technician. And we're not putting the vehicle first or the technician second, because we think, I mean, one is more important. I think they are both very important. So let's start with the vehicle safety first, guys. So
sure. Yeah, so like starting before we ask the questions, a lot of it came around, you know, the topic of, for myself personally, I've been an estimator and I've worked with technicians in the past, and I found that there was a lack or unsure knowledge of where to pull or get safety information for EV vehicles or information in general. So we came up with these questions where, as the estimator, I'm gonna ask questions as if I'm the estimator. So what would be some visual indicators that I, as the estimator, would look for or need to know in order to determine if a vehicle is unsafe or a non-drive vehicle for an EV vehicle?
Yeah, absolutely. So, I mean, it's going to be your standard vehicle intake process. We're going to do our walk around. We're going to make sure that there's nothing, obvious signs from the exterior of the vehicle that could pose hazards to us, high voltage wires being exposed, damage around the charging area of the vehicle. So we're going to want to do a visual walk around before we even touch the vehicle or enter the cabin, especially in a tow-in situation. Most EVs or hybrids or full electric cars have a disconnect, a high voltage disconnect, just like most combustion vehicles do. If an airbag is deployed or if the vehicle's in a severe collision, it will sever that high voltage system. But we always need to be careful, right? We don't know until we get an amp meter on there and check the system. So we want to do a visual cue. And then after that, we're going to open up the vehicle and we're going to verify that the vehicle does indeed power back up, right? And if the vehicle powers back up, we're going to start to look at the OEM repair procedures, figuring out where the high voltage components are on the car, because even model to model, those can change. So once we determine, is the damage around those components, are they indeed damaged? Do we need to remove anything to access those? So it's a really hard question to answer, to give you a specific, because there's so many variables, right?
So is there anything that we would need to know, like to be able to write an accurate estimate? If I'm an estimator, what would be some things we need to know in order to write an accurate estimate for an EV vehicle?
Yeah. So like I said, like we were just talking about in the previous question, anytime that we're working around a high voltage system, we need to have that information. What is required to power down the vehicle, and when does the vehicle need to be powered down? So those are important things to look at before we go any further into it. And then once again, I better have to refer back to that OEM repair procedure, really research what needs to be done. Sometimes when we remove high voltage components, they could be single time use. The hardware that holds those components on could be single time use. And all of those things are really important to know, because in a high voltage system, we're not dealing with a 12-volt circuit here. We're dealing with potentially 400 or greater volts. So if that hardware is a one-time use, it has to be replaced, because the Loctite or the adhesive that bonds that screw in will be used, and that screw could back out over time, opening up the gap between, say, a cable and a charger. And what is that going to create? A great deal of resistance. Resistance creates heat. We could potentially have a fire hazard. So even when we're looking at small things as one-time use hardware, it's imperative that we follow that OEM guideline. If it calls to replace it, it is non-optional. It has to be done.
Okay. So would an estimator or would a shop have to power down a car in order to write an estimate? Or is there certain circumstances when a car comes in to know when to power down the vehicle? Yeah,
it's a great question, because it's something that we actually talk about with our new estimators. We even talk about it with the customer service reps to make sure that everybody knows when is a power down necessary and when is it. And the great thing is, I'm going to repeat myself quite a few times, and I apologize. We're going to have to look at where are the high voltage components on the car, because that is the only really telltale sign of what requires a power down. Some vehicles, we could remove a bumper cover on the front of the car without powering down the car. Some vehicles in the rear bumper area, we have to remove the tail lamp to remove the bumper cover. The car has to be powered down because a charge port might be there. So it really has to be a case-by-case basis. What are we removing on the car? And obviously, is there a high voltage in the general vicinity of that? And that's really where those OEM repair procedures are going to come in, give us that information to say, oh, wait a second, there's a DC to AC converter here, I'm going to be around that area, I really need to power it down.
I think you bring up a good point too, because you had mentioned about like always finding out the specific vehicle, like the wondering if you have to power down the vehicle in order to remove a part. Mm-hmm. So like if you had mentioned that it depends on the manufacturer, you should always look at the manufacturer's guidelines as well in order to figure that out. So
absolutely.
What repairs would require the vehicle to be powered down? So do you power down every kind of car, or is it specific type of repairs? Can you do a minor repair without having to power down the vehicle?
Yeah. And so this is an important question. We get this from insurance appraisers coming to our facilities. They ask this quite often, right? So does every repair require power down? Absolutely not. There is repairs that we do not have to power down the car. The vehicle can remain high voltage live throughout the repair process, even in the paint booth. Now, once again, it matters on what component. So if we're working, for an example, on some of early model electric cars, if we removed a side marker lamp on a fender, there was a converter right behind it. So we would have to power a car down and remove a side marker lamp. Now that same model of car has gone through many upgrades. Now that component has been moved from the vehicle. So we're able to paint that fender without powering down the car. And I think that's one thing that we might touch on this in a further question, I'm not sure, but I think it's important to note is that just because we have an OEM repair procedure for one model of car 1 year, that repairs procedure can change. The one thing that I think OEMs are doing an amazing job with now is in model changes. So the exterior of the car might not change at all, but the high voltage components, location, type of high voltage components could all change throughout that model or platform life. So it's really important that we look up that repair procedure before we answer that question, internally in our shops to make sure that we know that there is nothing that's going to put, our staff or our customers at risk.
Okay, that's good information. Now, if a car is powered down, does that mean that the vehicle is now safe?
Yeah, so that's a great question. I mean, ultimately, if a car is powered down, can we do anything we want to the car? Is it high voltage safe? Absolutely not. So one thing that we all need to remember about a high voltage component is that unless we remove the battery from the car, that car still has high voltage in that cell, right? That encasement of the battery pack. So we cannot say 100% that car has been powered down. It still has high voltage. Some OEMs will mandate the battery needs to be removed prior to welding on the car. Some OEMs don't. Some OEMs will state that when we do a power down procedure, it has to be done at the retailer, but the car could have a permanent magnet motor. So if we push the car, say from a body bay to a prep station, we could generate in, let's say 100 meters, enough high voltage energy to potentially shock a prep technician or a painter. So it really is important. And I keep reiterating this point is that we have to know what we're working on and what the inherent risks are. And I can't personally answer every single question here because, like I said, it changes model to model and manufacturer to manufacturer. And that permanent magnet question is something that it really needs to be thought of, and it's well documented. If we look at through some iCar courses, for example, that there was some cars that you could not push when they were de-energized because of the motors. And then there is some that say, as long as the car is de-energized, you can put it in freewheel and you can push it forever, right? So it really, really is important that we know what we're looking at. We get that right information to the technicians working on the car. And the other thing to note, and I apologize if I've answered your question that's coming, is that it also needs to be not just the body technician needs to know about this, right? This is your entire repair facility needs to know about this. Your prep technicians, your paint technicians, your wash, your detail technicians, everybody needs to know because everybody is around that high voltage component at any given time. They're all walking through the shop, going to grab a tool or a brake or whatever it might be. And they need to know what hazards are in the shop. It's kind of like how we treat the paint department, right? Everybody needs to know what hazardous chemicals are in there, what risks are present. It's the same thing with high voltage.
Right, and grabbing that information is just going straight to the OEMs.
Yeah, I mean, like I said, the reason why I will continue to kind of push for the OEM procedures is there is great information platform out there that is generic and that gives you great overview of what to be aware of when coming to high voltage components and the risks that are incurred. But that OEM knows the power down procedure to make that specific component safe to work on. And I think that's why it's so important. And I kind of circle back to the motor concern or the drive motor concern is that, a permanent magnet motor versus non and what those two risks are inside the shop. And I think that that's why the only area, in my opinion, to get that information is the OEM. Yeah.
And probably the most current too, right? Like it's always, if there is changes, that it's always up to date on the OEM side. Yeah,
and one thing we always talk about in our shop is, we don't print OEM repair procedures. We don't have a binder, where with tags on it that says this is where you find that repair procedure, because as you alluded to, Vanessa, these change monthly, daily, weekly. We have no way to know. right? The only way to know is to look it up when the car is in our shop and we're actually touching and working on that car, what the repair procedure is at that exact time. I will recommend, if you're working on it, and this doesn't go just for high voltage components, if you're doing a structural repair and you have a repair procedure, you can print it, but put it in your RO file. Keep that for your record. So hopefully never, but if something happened down the road to a high voltage component or a structural repair, as I was saying, you have a record that, yes, on December 1st, 2021, this is a repair procedure for this car, and I have documented it, and it's in my folder. We did the up-to-date repair for that vehicle.
That makes sense.
Yeah.
Now, is the high voltage system the only electrical system in the car?
So this goes for,
Vehicle.
this goes for hybrids and full electrics. There is two systems on a car. There's a 12-volt system, which powers our accessories, our doors, our locks, the SRS system, right? And then there's a high voltage system. Of course, there's no alternator on a full electric car. That 12-volt system is getting charged by that high voltage battery. So in the event of a pyrotechnic fuse separating that high voltage component, or in the event of a power down, we can still open the doors of the car. We can still use the basic functions. We're going to have to support that 12-volt system with an auxiliary tender or whatever is required for that car. But there is two systems. And one thing that we have to know is, even though we just de-energized the car, the high voltage system, say it's removed, for example, we still have to be mindful. We can't go welding on that car because the 12-volt system is still connected. We could accidentally deploy an airbag or damage control modules because there's still current flowing through that car. So it's a great question. Right. It's something that I think is overlooked or maybe not thought about, but yeah, definitely is two systems on every car. And I think that for the foreseeable future, there always will be, because we want to sever the high voltage in a collision to make sure that first responders, occupants are safe, but we still need, airbags to deploy, our cellular phones to work for emergency services and so forth.
Okay. Now, what would be something that a shop would need to be aware of when the vehicle is going through the paint process?
Yes. So that is something that, once again, we need to look at OEM repair procedures, because almost all, and I'm going to say almost because there might be a model out there that somebody knows that isn't, but most high voltage batteries are climate controlled. And that battery climate control is actually more imperative to the car than the occupancy climate control system. So that car is going to do whatever it needs to keep that battery at a proper operating temperature. And if we put it into a paint booth and we start cranking the heat on, we could make that battery pack unstable. We could damage that battery pack. So it's very, very important to consult OEM repair procedures, and it will tell you not only your maximum bake temperature, but generally it will tell you the duration of time that that vehicle can be baked. And once again, we can do repairs, as we discussed in an earlier question, that high voltage is still present and live. But when we bake that car, we need to know what are the parameters that battery can withstand.
Absolutely, yeah. Now, what point do we decide to at what point do we re-energize the vehicle?
Yeah, so that's something that also, it's going to depend a little bit on the repair facility. It's going to depend a little bit on the repair, right? Sometimes in a repair, we might have to de-energize and energize a car several times throughout the repair. It might be to move the vehicle. It might be to verify functions of the vehicle. So there's really no set time of when the car can be de-energized or how long it has to remain de-energized. We may have to energize and de-energize that car several times. And that's something that I think, as we see the electrification of the automobile and this car park grow, that the OEMs are going to have to start to really look at. And I think that this is something that we all haven't thought about as an industry enough. So if we have 50% of the cars in a body shop in 10 years that are electric, and we have to sublet every one of those power downs to a dealership, well, there's a great deal of cost to that, right? And then also, as I said, well, what if I need to power the car back up to reassembly or to move the car, or whatever the scenario may be, right? So we might be looking at a car going back to a retailer 2-3 times during the repair. Is that feasible, right? When the car park is so large. And I think that the OEMs really need to have a look at what can we do to support the industry, the auto collision industry that is, so that they know how to properly work on the car safe. Because the big thing here is OEMs are the same as I feel. The last thing we want to see is a technician or somebody in the shop get hurt. And we all know that this is a new technology. We're all not 100% comfortable working around it, hence why we're having this seminar today, right? But it's so imperative that we work with the OEMs, and as these cars become more prevalent in the car park, that we know the shops need to have access to this information. The shops need to be able to safely power down a car and verify that it's safe.
Okay. Now, you brought up a point about saying that, you know, you're taking the vehicle back and forth to the dealer. Is that what's required in order to power up the car, or can you do it internal?
Yeah.
What would be the?
It really depends on the OEMs, Vanessa. So there's some OEMs that we're certified for that we can de-energize and energize the car in-house, and there's some that there isn't, right? Some of those cars do have to be flatbedded to the dealership, de-energized, and flatbedded back to the collision facility, right? So it really depends on the OEM and their repair procedures and what they're willing to have a certified or a non-certified body shop do, for that matter.
Okay.
Hey, Mark, this is fantastic information. I mean, you are like like an entire book of information here. It feels like we could listen to what you're saying forever. This is great. I mean, I really like this, and I was looking, you know, when I heard about, you know, spray boot, bake cycle. I mean, that got my attention, of course. And yeah, absolutely. So thank you for this. One thing I'd like to ask you, Mark, here before we move to the technician safety. Do you feel like, I mean, obviously you've been with Excellence for quite a while. Electric cars have been out for more than 10 years. There are some manufacturers that have been manufacturing electric only cars for more than 10 years. Do you feel, and then there's a lot of influx right now of new manufacturers and existing one, they're all trying to get their share. Do you feel like it's getting better, or is it more workable from a shop perspective, a technician perspective? Or is it, because I remember, you know, when the first airbags came out, I mean, the procedure was kind of complex, and you didn't want to work on a car with an airbag. And today, I mean, we don't even bother about that. I mean, it's different. I mean, it got a lot easier and all this. Do you feel like it is getting a little more workable, a little easier as the years and the more manufacturers comes in?
Yeah, so I think that it's because there's so many OEMs, as you were saying, Teresa, that are coming in really quickly, may or may not be trying to play catch up to other brands that already have a bigger car park. You know, I think that some OEMs are a little bit more lenient to allowing body shops to have that information, and some OEMs are still mandating the car go back to a retailer to have it de-energized. I think that the airbag reference is spot on. I do think that as time goes on and that car park gets bigger, and the faith that the industry has the tools and information to keep up to it, this will change. Right now, no, I don't think that the body shops, the mass body shops here, are able to safely understand and how to repair these cars. But we look at OEMs becoming more prevalent in certifying body shops. All of that is a positive thing, because all of that is laying the groundwork for helping body shops fix cars, you know, properly, but also working on EVs. So, you know, for any shop owners or managers out there that, you know, maybe don't have a certification or a lot of certifications, you know, I honestly think that is the way that you need to go. The industry is pushing it that way. It's not only for the structural repair, but it's going to be that link of communication between the body shop and the OEM. And if you don't have that ability to communicate regularly, you might be left behind, right? And so I think it's imperative that we try to bridge the gap right now so that we have open lines of communication.
Mark, there's one question here that came from another Mark here on the chat, and I'd like to bring it up here, and then we're going to move to the technician safety. So yeah. Mark's asking, can you touch base on other safety equipment needed for servicing and disconnecting? So like high voltage gloves, and how they need to be certified, and types of different battery tenders, and what should we be looking at, and where to find to find these things?
Yeah, so some of that might be covered in the next segment. Okay. We're going to get into personal equipment and so forth. But, you know, as far as the cars go, right, you know, this is something that also we look at, is that some OEMs have universal chargers, right? Some OEMs have, you know, vehicle or manufacturer specific chargers. But if we're going to start fixing electrified vehicles, we better have a way to charge them, right? You know, we can't go out and get a jerry can and put a couple of dollars of gas in this. We need to have a way to give that customer a vehicle back that has enough range to go. And that's another thing that we didn't talk about is these vehicles will consume like high voltage electricity, even if you're not driving them. So it's the same as any combustion car right now. As soon as you come up with your Bluetooth key fob, open and close the door, the car is going to power up and wake up and be prepared to be moved. And an electric car is no different, but you're consuming energy, right? You're consuming high voltage energy every time you wake the car up and the car goes back to sleep. So we see some of the OEMs have energy consumption over distance. So it's a graph that the customer sees. And we've actually explained it to the customers when they drop off. You are going to see a massive spike in energy usage over distance. This doesn't mean that our technicians drove your car. This means that we woke the car up 20 times during the repair and it went 0.2 of a kilometer. Because the customer's first mind is, well, I lent my car to my son or my daughter and they had a massive spike because they were going out and impressing their friends. That's what you guys must have been doing there. Well, in fact, no, like, you know, we take pictures of our kilometers. We can show you how few kilometers that car has moved, but we're using all of that energy. So the body shops will have to have a way to replenish that energy usage and make sure that we're, you know, giving a car back with enough energy to get to where the customer needs to go. But also with cold weather climates, as we all know in Canada, those, as we talked about in the paint booth, these high voltage batteries are thermal controlled, right? So they are regulating the glycol around the cells to make sure that that cell is stable. That car is parked outside in the dead of winter, -20. That auxiliary heater is going to be heating the glycol in that battery pack, consuming energy. So if you have a car at your shop and it's parked outside at -20 weather and you're waiting authorization, backorder part, whatever it is, you need to have a process in your facility where that car is being checked on. What is the status of the battery? How much voltage is left in the battery? Because it's just like any other battery. If you get that battery below zero, as far as state of charge, it's non-recoverable. Some of these batteries are $13,000 to $20,000 on average. That, you know, they vary a little bit, but you don't want to have to go to an insured or a customer and say, well, we forgot to maintain your battery. And now we got to buy a pack, because that's not claim related, that's negligence, right? So there's a lot going on, right? A lot to think about.
Yeah, well, thanks. I mean, you're generating a lot of activity here in the chat. Here, there's a lot of talks, and I see people sharing comments there, which is very exciting. Now, I think it's time now to probably move into what about the technician? I mean, this is now we're talking about the cars and all this, so this is all great. But I mean, the question was good about gloves and all these tools that we need to use. I mean, yeah, we're talking about a lot of voltage here, and that is, I mean, this can be, I mean, fatal. So let's talk about the technician safety here a little bit.
Absolutely.
Yeah, I guess maybe to start things off too is to answer the question that was asked is what personal safety equipment should a technician, an estimator, what should they be wearing when they're around an EV vehicle?
Yeah, absolutely. So there's a couple of things that, you know, the OEMs, if you're certified by the car, will mandate, what personal equipment we need to have. But I was thinking about this question a little bit earlier, and I think that the answer is that even if you're, and I don't condone non-certified shops doing non-certified repairs, but I'm saying that if you have a car in your facility that is a high voltage car, maybe it's time to invest in some of the essentials that we need to keep those technicians safe, some high voltage gloves. And the biggest thing is, and I'm trying to remember the terminology for the safety hook. So there's a safety hook, and it's sold, you know, you can go to any big power company, all supply chains. It doesn't have to be automotive, but it is a safety hook. And that is designed to remove somebody that is unfortunately being electrocuted. The big thing, and what we talked about a little bit on the vehicle side, is that we need the shop to be educated, because the worst thing that can happen is we turn one victim into 2, into 3, and 4, right? And that will happen is if somebody's unfortunately being electrocuted and your first human instinct is, I'm going to go help Vanessa get away from that high voltage component, but now I am a victim, right? So now it just moves down the line. And that's why it's so important to teach people. We want to help Vanessa. We want to get her away from that high voltage component. But if I'm enabled, I can't help her. And a training course to understand high voltage situational awareness, I think, is fantastic. It doesn't have to be done through an OEM. It could be done through, you know, an electrical company that has people that deal with it. I'm fortunate that I have some family that works for Hydro One. So even before my high voltage time with cars, I had some understanding of what is the precautions need to be taken, how do I treat this? And a lot of that personal safety equipment that the OEMs are mandating is from, likes of Hydro One or your power services, the 600 volt insulated gloves, right? Well, those gloves have an expiry date. Those gloves have to be tested, right? Because if there's a pinhole in that glove and you start to sweat because you're wearing this big, massive leather glove and you start dripping, moisture into high voltage component, that's going to be very bad, right? And the safety hook, like I said, teaching the guys, hey, this safety hook is by the hoist in the shop. Because if somebody gets shocked, this is the first thing you grab. You don't touch them, you don't touch the car, you get a hold of them and you yank them off as fast as you can, right? And I think that is so important for us to understand. And another thing that I perhaps should have touched on the vehicle questions is that if you have doubt that a car is not high voltage stable, the last thing you want to do is bring it into your repair facility, right? Because as we talked about, that battery is live. You don't know what the stability of that battery is. Park the car outside, park the car safely, tape it off, put warning signs on it saying this car is high voltage compromised. A lot of OEMs are running the battery packs very low in the car, brings the center of gravity down, makes the car more stable, but it's susceptible in some instances to punctures, right? So we want to make sure that if that car has been compromised, that we're not putting it in the shop, turning lights going home and then, lo and behold, the shop's gone the next morning.
When you mentioned the part about the technicians, like getting, if something were to happen, it gave me goosebumps because it was like, this is real. This is very real in our industry. And again, me coming from the experience of working in a shop, I feel that most people don't know the severity or would know to, my first offense would be to touch somebody to try to pull them off the car, right? So I think it's really good information to know. And, I like you said, with the sources of where to find to make sure that you have the proper training that's needed should something happen, because these vehicles are not going anywhere. So
and it's something that, like, when we look at our paint systems in our shop, we're all trained our staff on how to deal with a painter or somebody in the paint department that's overcome by fumes, right? We know what we need to do to that person. Well, it needs to be the same way, because you're right. I'm not trying to scare everybody, but high voltage, we can't see it. We don't know where it is, right? On a car, there's, we know that the cables are orange and we know that that's the battery pack, but we don't know if it's contained to that or if there's, a compromised pack where there's a cut in the wiring insulation. And it's something that you have to know what you're dealing with, because the last thing I want to see or this industry wants to see is a fatality because somebody wasn't trained, right? And I can't emphasize that enough, that it does have to be treated seriously. It is not something that every technician in your shop might do, right? It might be saying, hey, you know what, I've got, Vanessa and a technician in the shop that they're really keen people. They care about safety. They're not easily spooked or rushed. I'm going to work on that car. That's the people I choose, because there's repairs that we do on some OEMs. When the car is de-energized, we are still working on high voltage components live. There's no way to power that down, as I was saying earlier, the battery pack. And you don't want any technician doing that repair. You don't want a technician that, their significant others on the phone and they're going to rush to that phone call, or they're not focused 100% on the task at hand. Because like I said, the last thing I know anybody on this call, because you're obviously interested and engaged in what we're talking about here, wants is somebody to get hurt, right? Or quite honestly, to be killed. So it's something that really needs to be taken seriously.
So let me ask you this. A car comes into the shop for an estimate, customer's driving the car, and I'm the estimator. Do I need to put the gloves on?
So you don't need to put the gloves on unless you're working on high voltage components.
It's only when you're working on the high voltage.
Yeah, or you have reason to suspect that a high voltage component has been compromised.
Okay.
So, you could have a customer drive their car parting into your facility, and it could be high voltage unstable. The battery cell could be damaged. It could be a rear end collision, it could be underneath, depending on where the pack is. And just because the car is mobile doesn't mean that it's safe. And that's, once again, why we walk around the car, why we look at it. If it is a car with a low mounted battery, why we look underneath the car, make sure that we don't see any obvious signs. We're talking about 5-10 seconds to walk around a car and look underneath of it, to give you the peace of mind that, yeah, you know what, this car is safe to touch, it is safe to work on.
Okay. Now, how do I access safety information? If I'm looking for information, how do I access it? Where can I go?
Yeah. So one thing that I think is really cool, one of the OEMs that we work on actually puts a QR code on the driver's door of the car. I think that you're going to see more of this. I think maybe when government agencies get a little bit more up to speed on this, that we might see more QR readers on driver's door by the VIN number area. And that is something I think needs to happen. And once again, it's not because I do believe that car needs to go to a certified shop, but I do believe the general public, the customer, the shops, the technicians need to have a quick understanding of what they're dealing with. And because it's so new technology in the industry, I think that's something that we could see. But otherwise, I'm going to, basically mandate that we go to the OEM repair procedure to understand what we're dealing with.
Okay. And it's a good question. So what do I do with a high voltage components once we remove them?
Yeah. So once again, a high voltage battery pack, sometimes the shops will be allowed to remove that pack during a repair. It depends on the OEM, of course. But once that pack is removed, it is not a parts bench. It is not something that we push into the corner and we don't think about, right? That is a live high voltage battery and it needs to be treated as some. So it needs to be cautioned, barricaded off with some ropes. It needs to have some signs put on it so that somebody doesn't walk by and use it as a resting table, put some parts on top of it as a storage unit. Once again, we're trying to make sure that everybody in the facility understands that that pack, although the car is de-energized now, we removed that high voltage power source. That power source is still alive, even if the car read 0 when you took it out. So almost all EVs are the same. If the kilometer range reading 0, there is still a high voltage battery in the car. A general rule of thumb, please, remember we're talking about every OEM that is making EVs right now. It can range from 10 to 20% reserve after 0. And they're doing that. So if a customer runs the car out of battery, but gets the car towed to a charging station in a reasonable amount of time, the battery will not have to be replaced. So we remove a pack, the range since 0, that is still a high voltage battery.
Now, just to summarize too, I was just thinking back to the equipment that a technician would use. So primarily we're going to have the hook, whatever that name is, and then we're going to have the gloves and then goggles, signage. Do they have to wear a specific outfit?
Yeah, so the
shoes.
The biggest thing we remember is jewelry, eyeglasses, little screwdrivers in our pockets, all of that stuff is gone.
Okay.
If you wear eyeglasses, we get them tethered off behind our head. So if they do come dislodged, it's not going to fall onto the high voltage component. And then signage, right? We want to make sure that if an appraiser, a customer is walking through the shop, they know, hey, that's not something, whatever is happening over there is not somewhere where I'm welcome, right? It's not somewhere that I'm going to go up and put my nose in and see what's going on, right? And you use that signage because say a customer comes in and they forgot their cell phone charger in the car, right? The technician's on lunch, right? I'm just going to walk up and going to grab that part out of that car that customer needs because they're standing in my office. Well, that car could be in the middle of a high voltage power down or power procedure, right? So we got to remember, we need to make it so obvious that if you're not directly involved in that repair, you can tell, wait, there's a big caution sign and some tape. I'm not going over there today.
Okay, so I have one last question for you. And this is just an general overview question is, are EV vehicles safe in any collision center? So
that's a tough question to answer. My personal answer is yes. EVs, hybrid cars are incredibly safe. I think sometimes we look at how it's portrayed in the news cycle. It makes us feel that they aren't safe. They are incredibly safe. There is so many fail safes built into these cars to keep the people, first responders, technicians safe. It's unbelievable. But we are dealing with cars that have been involved in severe collision at time. So maybe those safety functions aren't working as properly designed because of the severity of the collision. So my general answer is yes, they are extremely safe to work on, but we are not in a controlled environment. We are not in the car came in for a tire rotation or a brake job. We are in, this car has been involved in some form of collision. We don't know what it is, so we need to act like it's not safe. And there's certain repairs that we can do at a body shop that, yes, are very dangerous if we don't know. And I kind of go back to that, to the beginning, the whole time throughout this interview, we've talked about the most important thing is to give your staff the access to the information that they need to know. Because, you know, I'm a huge proponent of fixing a car right. It has to be fixed right, because we don't want to deliver a customer a car that is not safe to be involved in another collision on the road. We don't want to give our technicians a job that isn't safe for them to complete. And that's our responsibility as managers and shop owners, to make sure that they have the access to the information, and then challenge your technician. Say, okay, Vanessa, I see you're working on this high voltage car. Where's the repair procedure? Show it to me. Challenge them, because we all get complacent in life, right? We can all agree that we've all thought that's not going to hurt me, right? And the problem is 9 times out of 10, you might be right, but the one time you're wrong, unfortunately, it could be fatal.
It's not something you want to risk.
Yeah,
that's for
absolutely.
sure.
Absolutely.
Hey, Mark, there was a question earlier. We talked about the glycol, kind of the heater and also the refrigerant, I guess, at some point, depending on what time of the season it is. There was an interesting question from a listener here asking, I guess that this glycol is not necessarily a conductive liquid. I mean,
Yes.
that's what I would think. And the other is that if there's a leak, I mean, that should definitely be a visual indicator that there's something wrong, or there is something damaged, or something like this. And does that really leak, or is that more of a gel than a liquid?
Yeah. So the couple points to the question there is, yes, the glycol that's used in the car is special glycol, depending on that OEM, right? Of what they need that glycol to do and where it's traveling throughout the high voltage system. The important thing to note is these cars on the road, they all have cabin, comforts, right? They all have heat and AC. That same glycol that's doing that is taking care of the high voltage system. So if you have a car that's come in and the front radiator, because it does have a radiator, is leaking glycol, that car cannot be driven. It needs to be properly cared for, because we know that battery might not have a sufficient amount of glycol to keep it stable, right? And to kind of touch on your point, yes, it is important to note that this glycol will either be run through a chiller to cool it down if the car was in the desert, or if you were using the car in a high performance situation, or it needs to be heated in an extreme cool. So we need to make sure that battery has the appropriate amount of coolant in it. Now, the one thing I would say is that if we're removing a battery, I'm sure maybe the person that wrote that question is thinking, well, Mark, if you take the battery out of the car, it doesn't have glycol in it anymore. Correct. That's why we're keeping that battery at close as possible to room temperature. So it is stable. It is not being under load, right? And we know that battery is, we're not going to take that high voltage battery and we don't have room in the shop and we're going to push it outside for the day. We're not going to do that, because we're putting it into a cold or a hot environment.
Yeah. Now I do have a question. As I was listening, I'm saying, yeah, okay. So, if I'm a shop operator, I'm doing this, and I'd like to hear about how you guys are doing it at Excellence. Do you have like a separate workflow for electric cars, meaning that only certain technicians will touch the car because they know it's an electric car, they know what to do, or because of the nature of the beast here, it requires a separate workflow? How do you guys handle that?
So because of the amount of OEMs that we're certified for, a lot of our technicians are specialized with certain brands. So we might have, it would depend on the brand, but as we're talking about, all of the brands that we currently service have a hybrid or EV in them. So all of our technicians could be working on a high voltage or component at any time. But the important thing is that they are certified to work on that car, so that they have the understanding of what that system is. Because believe me, the 6 OEMs, and soon to be more, that we're certified from, the power down procedure is so different. It is absolutely shocking how different they all treat it. Right now, in theory, we're all doing the same thing. We are severing the connection, but how that is done is really interesting.
Yeah. Very, very nice. There's a question here that just came up asking if insurance companies are being educated on EV repairs. I know insurance appraisers, I know folks who are working at insurance company, and yes, they are, absolutely. So what do you think, Mark, here? Yeah.
I mean, at the end of the day, I think the insurance companies are definitely aware of the situation. Ultimately, they're carrying the liability coverage on that car, so they have to be aware of what they're insuring. But I think that the important thing to note is, once again, as we talked about a little bit earlier, that information changes so fast. So you as the repairer need to have the most updated information and share it with the insurance appraiser and share it with the company. You're not hurting anybody by sharing the information. You're doing the exact opposite. If you have to charge to power down a vehicle, the worst thing you can do is just, I have to power down because I have to do it. Well, no, explain it to them. Maybe share with them what you're allowed to share as far as the power down procedure goes, so they can understand what they're paying for. At the end of the day, the insurance company is not going to say, well, we're not going to pay you to power down that car, Mark, because it is absolutely necessary for the repair. And just as we're all humans, nobody wants to see somebody get hurt, right? That's it. It's just not the case.
So very interesting. I mean, when you said that even if the car reads 0, I mean, there's still a power reserve, and it totally makes sense to me now. I mean, I would have never thought of that, but it makes total sense. You don't want the battery to go completely dead. So they keep a little bit of life into it, but they tell the driver that no, you can drive this car. I mean, it's just out of power.
Yeah, the car would actually turn off. So at 0 range, the car will not be mobile anymore, right? Yeah. It's the same as your smartphone. When your smartphone turns off, it is not at true 0. It's not unusable, right? But you can plug it back in and it's going to come back to life, right? As long as you do it in an appropriate time frame. And these cars are the same way, right? It is a very big smartphone.
Yeah. So this is good. So hey, I think that probably one more thing I'd like to discuss here, and is what about the resources? I mean, we've been talking about OE. And we understand that the ultimate resources of place to find information is the manufacturer. They build a car, they know what it is, they know what it does, they know how to handle that. Is there any other sources that the folks that are listening to this, I think we have almost 130 people here on this call, that can look up to or can find some piece of information?
So, I mean, I will kind of use an industry standard. We can go to ICAR, the likes of that, and we can get a general understanding. And I think that even for shops that aren't certified, but they might have a car in, encourage or mandate your staff to take that high voltage awareness training so that we have a basic understanding. We know we can't do that repair, but we know, once again, what to look for when we're doing that first visual inspection, right? We know, okay, I see a high voltage component. I know enough to what to look for. I know those telltale signs of, hey, I need to use extra precaution here. So even if you're not certified, I would employ everybody, take those steps to get your basic fundamentals down so that at least you've given your staff the knowledge of, hey, I'm working around this vehicle. It might be here for a repair, it might not be, but I know how to react safely to it. Yeah.
So I have a Mark here in the chat that says that all data has some information. I know that I think Mitchell also has some information. ICAR is definitely, I mean, they've definitely enhanced their site to provide more information. But yeah, interesting. That it really is an interesting thing. And as you mentioned, Vanessa, I mean, those cars are not going anywhere. I mean, look at although the big car manufacturers, I mean, they're all making the turn. And Volkswagen is extremely aggressive. I mean, they have targets that are absolutely unbelievable, and all the other manufacturers are well, and a lot of new manufacturers that are coming into market too. So it's great.
Something I will share that I found interesting, right? So we were speaking the other day, just having a general conversation. It doesn't really have to pertain to the safety component of this topic, but somebody once said to me, well, Mark, what's going to happen when these cars are off the road with these thousands and millions of high voltage packs that are laying around in scrap yards, for example, or salvage yards? So one thing that we have to remember, and it varies from OEM to OEM, but the ballpark is 80 to 90% of the components inside that pack are recyclable. So that's a huge amount of that battery that can be repurposed or reused. And when we think about a combustion car, well, how much gasoline after it's been put out the gas pipe can we reuse? 0, right? So it is more environmentally sustainable to have electric cars if we can continue to grow that refurbishment and maybe push that number past that 80-90% mark, right? But there is processes put in place, and companies, these startup companies that are coming online and realizing, hey, there's a huge market here. The raw materials that are inside those packs aren't cheap. It's the lion's share of the cost of these cars. right? So if we can find, these companies continue to develop ways to refurbish that and get to that 90% plus mark, there really is a path forward for a greener car park.
Hey, this is absolutely fantastic. Thank you. Thank you so much, Mark, Vanessa. Good job. I mean, this is, wow. Geez, I feel like I should be watching the recording when it comes out, because I probably didn't get 100% of it, but this is good. And I can see that the audience we really enjoyed that. So thanks again. Thank you very much for everybody for attending. I'm just going to be bringing my closing slides here on the screen. So thank you again so much, everyone. Again, you can look at the recording. In a few days, it should be edited and out and available on the CCIF.ca website. We do have another webinar tomorrow. This one is about recruiting and attracting students. So, and that's going to be a panel discussion. So we have people from the Collision Repair Education Foundation south of the border. We have Thadi from Skills Trader, and we have Scott from some Sask Polytech, who are going to be talking about this. So that is going to be an interesting session as well. So, hey, thanks everyone. Almost 130 people attended today. So this is absolutely great, fantastic. A lot of activities on the on the chat and on the Q&A. So thanks again. This was a fantastic job. Thank you to our sponsors. As I said at the beginning, this would not be possible if we wouldn't have this. Mark, excellent. Soto, Vanessa, thank you guys. Good job. And we'll stay in touch. So thank you very much. And please, everyone, enjoy the rest of your day.